Hi students, welcome to Diamond Group of Institutes, NEET and K-CET online classes. Today we are going to discuss about the electrostatic potential and capacitance. So once practice all the formulas from your material. Okay, the first question is, charges are placed on the vertices of a square as shown. Okay, so in the figure they shown here, this is the square and the charges are placed like this. Let E bar be the electric field and V be the potential at the center. At the center we have the electric field is E and the potential is V. If the charges on A and B are interchanged with those on D and C. Okay, this point we have to remember. The charges at the on the A and B interchanged with those on D and C respectively. Then they given the options. Now see the first one. See the diagram. A, B, C, D, here positive charge, negative is there. So now same diagram I am drawing here. So at the center electric field I am going to find. Suppose I am assuming one positive charge is here, unit positive charge. You can assume negative charge also, nothing will happen. So I am assuming positive charge, unit positive charge. Due to this positive charge, electric field direction is away from this one, so in this direction. Okay, so electric field, if positive charge is there, away from that one, negative charge, for negative charge toward it. So here negative charge is there, electric field is toward it. So that means both the electric field are in the same direction. And due to this Q charge, positive charge, away from this one, so in this direction we have. And due to minus Q, negative charge, electric field is in this direction. This both electric fields are in the same direction. So add up these electric fields and add up this electric field. So the resultant of these two electric field we will get in this direction. That means from this diagram we are getting the electric field direction is in downward direction, vertically downward direction. Now according to the question, the charges at the A and B are interchanged with those on D and C. A and B we have the positive charges, D and C we have the negative charges. So A, D interchanging, B, C interchanging according to the question. So minus Q will come to the A position, Q will come, positive charge will come to the D position, negative charge will come to the B position and positive charge will come to the C position. Now I changed A at the negative charge, B at the negative charge, C at the positive, D at the positive. Now once again assuming the one unit positive charge, same charge here, and finding the direction of the electric field. So see now, due to this negative charge, electric field direction is in this direction. Okay, first to see the corner charges, so here in this direction. Next to see the positive charge, due to this positive charge, away from this one in this direction only. So both the electric fields are in the same direction. Now come to see the negative. So due to this negative charge, electric field is in this direction. Due to this positive charge, away from this in this direction. So here this electric field same direction, here the two electric fields same there. Add up and resultant of these two will be in the vertically upward direction. So by interchanging the charges between A and D and B and C, we are that means electric field direction is changing. Here vertically downward direction and here vertically upward direction. Okay, remember electric field direction changes here. Now come to see the potential. So potential formula V equal to the K Q by R. This formula remember. Okay. Next, potential is a scalar. Okay, it has only magnitude. It's not depend on the direction. At this center, okay, at this center, what is the potential? So the potential at the center V equal to the, due to the positive charge plus VA, and due to this positive charge plus VB, due to this negative charge minus, sorry, C is here, D is here. Okay, due to this negative charge minus VC, due to this one minus, if charge is negative keep the negative sign, charge is positive keep the positive sign. That means we are getting the resultant is this one. If we interchange this one, minus Q here, okay, and plus Q here, minus Q here, plus Q here also. If we interchange the charges, the potential at the center not changes. Whatever the value we are getting here, after interchanging also we will get the same potential. That means potential not depending on the but interchange of the positions. So from this what we are getting, by interchanging the charges, electric field is changing but potential is not changing. The option is electric field is changing changes and the potential is remains unchanged. A option is the right answer. Now come to see the second question. A hexagon. Hexagon means 6 sides. Of side, each side ka length also they given 8 centimeters. Has a charge 4 microcoulombs. 4 microcoulombs charge at each of its vertices. That means at each corner it has the 4 microcoulomb charge. The potential at the center of the hexagon is at the center we have to find. Okay, so now according to the question, this is the hexagon and each side ka length is same 8 centimeters, 8 centimeters, and at 4 microcoulomb charges located at each vertex. So here 4 microcoulomb, 4 microcoulomb, 4 microcoulomb. At the center we have to find the potential. So see now all the charges are identical, okay, and we have to find the potential at this point. Potential ka formula is V equal to the KQ by R. So now here all the charges are identical, all are positive only. Okay, so then charges, okay. Next distance. See now this is the total angle is 60 degrees. Now hexagon each angle is nothing but here 60 degrees. This is 60. All these are the 60, 60, 60. Okay, 60 degrees. Now the vertices are, all the vertices have the same distance from the origin, center. From here to here distance is same. Here to here distance, here to here distance, here to here distance. All distances are same here. That means these two distance also same. So here these two sides are same means the opposite angles. Here also these angles are the equal from your mathematics. That means here the 60 degrees remaining. This is the triangle it is forming. Total is a 180 degree. Here 60. Remaining angle is 120 degrees. These both are divided into equal part. That means this is 60. This is also 60. So this is forming the equilateral triangle. So if this side is 8 centimeter, this is also 8 centimeter, and this is also 8 centimeter, and all these are 8 centimeter distance only. That means the center, to find the potential at the center we have the identical charges, and these charges also same distance from the vertices to the center. So we can write, so the potential due to this one is the KQ by R, potential due to KQ by R, KQ by R, KQ by R, KQ by R, KQ by R. How many charges are there? How many vertices are there? 6. So 6 into KQ by R. If the charges are identical and if they are same distance from the origin, then we will use the like this. So 6 into K value we know 1 by 4 by epsilon naught, or 9 into 10 power 9. Okay. Charge, each charge is nothing but the 4 microcoulomb, 4 into 10 power minus 6 by R. R is nothing but the length of this side. So side ka length is 8 centimeter. So 8 centimeter is nothing but the, convert into the meters, 8 into 10 power minus 2. So then simplify, we will get the answer 2.7 into 10 power 6 volt, 2.7 into 10 power 6 volt. And come to see the next question, third question. 8 small drops. How many drops? 8. 8 small drops, each of radius r and charge q. Radius is r, charge is q, are combined to form a big drop. The ratio between the potential of the bigger drop and smaller drop. Remember this one, bigger to the smaller or smaller to the bigger. What are they asking in the question? That we have to concentrate. And remember this formula, instead of doing the so much derivation, if you remember this one, here the what you have to remember means the ratio of potential of bigger drop to the smaller drop. Okay, don't write smaller to the bigger, bigger to the smaller. Potential of bigger drop to the potential of smaller drop equal to the capital N power 2 by 3. N is nothing but the number of drops. So here how many number of drops here? 8 smaller drops are combining and forming a big drop. Okay, so now the potential of big drop to the small drop equal to the 8 number of drops are there, 8 power 2 by 3, and 8 we can write 2 power 3, 3 will be cancelled, we will get the 2 square, and big drop by smaller is a 4 by 1, 4:1. Answer is the 4:1 right answer. If they ask the small by big, then we will get the 1 by 4, 1:4. So concentrate on this one. They are asking big to the smaller, small to the bigger. Okay, now the next question, fourth question. 3 charges plus q minus q and plus 2q, plus q minus q and plus 2q are placed at the vertices of a right angle triangle as shown. So this is the diagram they given. The net electrostatic energy of the configuration is, the system ka electrostatic energy we have to find. Okay, here plus 2q, either plus q, either minus q, and distance from here to here is a, from here to here it is a. Okay, right angle triangle they mentioned. Okay, I am redrawing this diagram here. So plus 2q plus q minus q. I am assuming this is first particle, second, third, q1, q2, q3, and distance between these two is a. Distance between these two is the a. Right angle triangle from Pythagoras rule we can find it. So this is a, this is a, means this is nothing but the root 2a. So now they are asking the electrostatic energy. So electrostatic energy formula is U equal to the K into Q1 Q2 by R. Potential की K into Q by R, potential energy or electrostatic energy nothing but Q, K into Q1 Q2 by R, product of charges by distance between them. Okay, so now here to find out the potential energy of the system, how many pairs are forming? See now. So the potential energy between these two, one pair, potential energy between these two, one pair, potential energy between these two, one pair. Three pairs are forming here. So the total potential energy of the system is equal to the potential energy between these two, potential energy between the first particle and second particle, plus potential energy between the second and third. So U is due to the second and third, and potential energy between the third and first. So sum of this potential energy will give the potential energy of the system. Okay, now see the formula. We know the formula already. U equal to K into Q1 Q2 by R. So U equal to the potential energy between the first particle and second particle. So product of charges plus 2q into plus q plus 2q square. So 2q square by distance between them a. Okay, second one, so the potential energy between the second and third particle plus q into minus q, plus into minus minus q into q square minus q square. That's why here I kept the minus k into q square, and distance between them a. And next potential energy between the second and third particle plus 2q into minus q minus 2q square. So I kept the minus. So k into minus k into 2q square. Already I kept the minus by distance between them is root 2a. From here kq square by a is the common. So from here 2, from here 1, from here 2 by root 2. So kq square by a equal to 2 minus 1 is the 1, minus 2 by root 2 is nothing but the root 2. So once check the options, kq square by into 1 minus root 2, either root 2 minus 1, either root 2 minus 1 is there. So just take the minus as a common, then minus kq square by a root 2 minus 1. So see the minus sign is there here plus sign is there, either minus sign is there. So this is the right option. Take care about the options. Okay, next see the next question. The electric potential at point x comma 0 is, this is the given potential. V equal to 100 by 1000 by x plus 1500 by x square plus 500 by x cube. Calculate the electric field at point x equal to the 1 meter. So already you have to remember this formula, the relationship between the electric field and potential. E equal to the minus del V by R. Okay, now changing the potential by displacement we can write. So now E equal to minus dou V by R. If we write this formula in the form of the Cartesian coordinates, that means in the form of x, y, z, then we will get minus of dou V by dou x I cap plus dou V by dou y j cap plus dou V by dou z k cap. This is the formula. But here the potential is only x component, it has no y component, no z component. Then I am going to write the electric field formula E equal to minus dou V by dou x I cap only. So y component, z component we don't have. So just I am writing the dou by dou x. So now minus dou by dou x of V value. V value is 1000 by x plus 1500 by x square plus 500 by x cube. So same thing I am writing I cap. So now from this 500 I am taking as a common. Then here 2 by x, 1500 and 5 to multiply 3 times. 3 by x square, 500, 1 by x cube I cap. So now here minus 500 into. Differentiate this one. Okay, 2 is same. 1 by x ka differentiation minus 1 by x square. So minus 1 by x square into 2 minus 2 by x square. Minus 2 by x square. So 1 by x square ka differentiation is minus 2 by x cube. Minus 2 by x cube into 3 minus 6 by x cube. Minus 6 by x cube. 1 by x cube ka differentiation is minus 3 by x power 4. So minus 3 by x power 4. Same. And they are asking the electric field at x equal to the 1 meter. So write down the x equal to 1 here. Here 1, 1, 1. So minus 2, minus 6, minus 3 we will get. So this is nothing but the minus 11. Minus into minus plus. 11 into 500, 5500 I cap. So answer is the 5500 I cap is the right answer. Next, see the sixth question. Equipotential surfaces are shown in figure. The magnitudes of the electric field is. So here, the given the diagram. I am redrawing the diagram here. See now. So 10 volt, 20 volt. This total surface at every point we have the 30 volt only. Here the 40 volt we have. So equipotential surfaces. So electric field ki equipotential surfaces ki some points you have to remember. In the direction of the electric field, potential decreases. Opposite to the electric field direction, potential increases. So now from here to here, potential increasing, 10 volt, 20 volt, 30 volt, 40 volt, increasing. So now electric field I am taking opposite direction. That means in this direction electric field is increasing, opposite to electric field potential increases, but in the same direction potential decreases. In the same direction see potential is decreasing. Here 40, 30, 20, 10, potential is decreasing. So I took the here electric field direction. And the next one more point you have to remember, electric field perpendicular to the equipotential surfaces. Okay, so these are the equipotential surfaces and drawing the perpendicular to the equipotential surfaces. Okay, so electric field is perpendicular to the equipotential surfaces and electric field is potential is decreases in the direction of the electric field. Remember these points. And next we have the formula. So del V equal to the E into dr. Okay now, so from here we have the E equal to minus dou V by dou R, dou V equal to E into dr, E dot dr, otherwise E dot dr. So now here see, I am considering the displacement between these two equipotential surfaces. I am drawing one perpendicular line. This one are parallel to each other. That means E dot dr is nothing but E dr cos theta. Either these two are the parallel to each other. So then theta equal to 0 degrees cos 0 1. So we will get the E dr only. So now this dr we have to find. Dr is nothing but the displacement we have to find. I drawn here perpendicular line. So now this angle already they given 30 degrees. This angle is 30. This is also 30 degrees. From this triangle, so here it is the 90 degrees. From this triangle, sin 30 equal to opposite side is del r by hypotenuse is this is. So from here to here, what is the distance? This 10, 20, 30, 40 means this is the distance is not between the gaps. So 10 from origin to here 10, from origin to here 20, from origin to here 30, from origin to here 40. That means the distance between the equipotential surfaces is 10 centimeters. So now from here to here 10 centimeter and this is the del r. So sin 30 equal to opposite side by hypotenuse del r by 10 centimeters. So and we need the del r equal sin 30 value is 1 by 2, 10 cent this side 10 by 2. So 5 centimeter we will get. So now del V equal to the minus E dot dr. Why we will be keep the minus here means, so the potential decreases in the direction of the electric field, it is indicating. But here I am taking the electric field in the opposite direction to the potential only. No, that's why no need to take the negative also here. Del V, the difference between these two potential, so equipotential is nothing but the 20 minus 10 is 10 volt. E dot dr value. So okay, the displacement between the equipotential surface is the 5 centimeter. 5 into centimeter converted into the meter 10 power minus 2. E equal to the 10 by 5 into 10 power minus 2. Simplify, we will get the 200 volt per meter. 200 volt per meter is the right answer. Like this you have to do the problems. Next question, 7th question. Find the effective capacitance between points A and B in the following figure. If C1, C3, C4, C5 equal to the 4 microfarads and C2 equal to the 10 microfarads. Okay, so the unit of the capacitance is farads we will measure. So now this is the circuit diagram they given. C1, C2, C3 and here C4, here C5. So how many resistors are capacitors are there? Count it. 1, 2, 3, 4, 5. 5 capacitors are there. One thing you have to remember, if 5 capacitors are there, immediately the Wheatstone bridge has to strike in your brain. So next do in that way only. So now I am redrawing the diagram here. I am giving the numbers. Here the A point and the next either the potential is X, there Y and either B. So I am rearranging this one. See, A point here, X here and Y here, B point is here. So A to X we have the capacitance C1. So A to X capacitance is C1. And X to Y we have the capacitance is C2. Okay, X to Y capacitance is C2. And the next Y to A. So Y to A we have the capacitance C4. And next Y to B we have the C3. So Y to B we have the C3. And B to X we have the C5. Okay, now Wheatstone bridge formed. So now here we are getting the same ratio or not, that we have to check. C1 by C5. C1 C5 both are equal, so C1 by C5 equal to the 4 by 4 1 we will get. C4 by C3, C4 C3 also equal, 4 by 4 we will get the 1. So this ratio is equal to this ratio, then this is in the balanced Wheatstone bridge. Now remove this one. Okay, remove this capacitor. After that I draw the equivalent circuit. So these two capacitors are in the series and these two capacitors are in the series and remove this part, this branch. Okay, after this one. So now these capacitors are in the series, these capacitors are in the series. So the equivalent resistance for the equivalent capacitance for the series combination, 1 by CS equal to 1 by C1 plus 1 by C2, just opposite to the resistors. Okay, so in parallel combination we have this formula in resistors, in series combination we have the resistors. So opposite to the resistors we have to remember. So 1 by C1 plus 1 by C2, like this. Here C1 value is 4 microfarad, C5 value is 4 micro. 1 by 4 plus 1 by 4, 2 by 4. 2 by 4 value, 1 by CS equal to 2 by 4. 2 by 4 means 1 by 2. So CS equal to 2. So resultant of this is 2 microfarads. Same way find this one also 2 microfarads. Now these two are in the parallel combination. So the parallel combination, the total resistance equal to C1 plus C2. Add up 2 plus 2, 4 microfarads. So the answer is the 4 microfarads. So easy problem, solve it. You may get this type of problems. Now see, plates of area A are arranged as shown in the the distance between the each plate is D. The net capacitance is. Net capacitance we have to find. See, now they are given the diagram here. 1, 2, 3, 4, 5, 6 plates are there. And the second plate is connected to B, and here fifth plate is connected to A, and first plate and fourth plate is connected by the wire, and third plate and sixth plate connected by the wire. So I am redrawing this diagram here. See now. So here how many plates are there? 1, 2, 3, 4, 5, 6. 6 plates are there. So 6 plates are there. Number of capacitors are n minus 1. So 6 minus 1, 5 capacitors. Easily you have to draw. If 7 lines are there, 6. If 10 lines are there, 9. So like this, n minus 1 capacitor. I am drawing the 5 capacitors. 1, 2, 3, 4, 5 capacitors. And the next B is at the second plate. So and the numberings I am giving to you 1, 2, 3, 4, 5, 6. So here also I am giving the number 1, 2, 3, 3, 4, 4, 5, 5, 6. And the next B is connected to the second plate. So B is connected in between the second, here to either to between the second, and A is connected to the fifth plate. So 5, 5 between this one we have the A, and 1 and 4 are connected by the wire. So 1 and 4 connected by the wire, and 3 and 6 connected by the wire, and 3 and 6 connected by the wire. This one 3, between this one 3 to 6 wire. So now here one more thing, based on the same previous problem, here 5 capacitors we have, then get the immediately Wheatstone bridge idea. Okay now. So now see here, either I am assuming X, then either this is the wire, so either potential and either potential also same, and here I am assuming as a Y, here potential and here potential also same. Now A, B and X, Y I am taking. So X to B on capacitor is there, X to B on capacitor, B to Y, B to Y, Y to X, Y to X, X to A, X to A, and A to Y, A to Y. Like this we have to draw the capacitors, we will get the Wheatstone bridge. This is the balanced or unbalanced, we have to check. So all the capacitors have the same area, same distance, then all have the same capacitance. So capacitance value I am assuming CC. So the ratio of these two capacitors C by C1, the ratio of this capacitor C by C1. So the ratio of this side and the ratio of this side is same, then remove this one. Okay, then we will get these two are in the series combination, these two are in the series combination. Series combination of two equal resistance. 1 by CS equal to 1 by C plus 1 by C, 2 by C. 2 by C means CS equal to C by 2. So now we will get the this equivalent resistance of this 2 is nothing but the C by 2, equivalent resistance this 2 is nothing but the C by 2. Now this combination is in the parallel, so add up this C by 2 plus C by 2, C. Okay, the capacitance formula already you know, C equal to the epsilon naught A by D. So we got the answer C, epsilon naught A by D, epsilon naught A by D, A is the right answer. Now come to see the 9th question. A network of 4 capacitors. Here we have the 4 capacitors of capacitance given C1C, C2, 2C, C3, 3C, C4, 4C is connected to a battery as shown in the figure. What is the ratio of the charges on C2 and C4? So now we have to find the charges. charges flowing through C2 and charge flowing through the C4 we have to find. In the capacitors you have to remember one thing, if the capacitors are connected in the series, then charge developed across the capacitors is same. Okay, and if they connected parallel, potential difference is same. If they connected in the series, charge is same. Okay, and the next see now, first I am redrawing the diagram here. See now, these three are in the series, so I am writing the series combination. These three are in the series, so CS, and this is the C4 and voltage is same thing I am writing. So the equivalent resistance of these, equivalent capacitance of these three capacitors I am finding. So 1 by CS equal 1 by C1 plus 1 by C2 plus 1 by C3. So C1 value C, C2 value 2C, C3 value 3C. Substitute and simplify, we will get the 1 by CS equal to 6C by 1 by CS equal 11 by 6C, CS value equal to 6C by 11. That means this value is 6C by 11 we got. Okay, now these two are in the parallel combination. Okay, so potential difference across this one, potential difference across this one is same. Okay, now these three resistors are connected in the series. The charge flowing through these three is the same. So charge flowing through the three resistors, Q1 equal to Q2 equal to Q3. Okay, are same. So that is equal to the equivalent resistance into potential difference across that equivalent capacitance and potential difference across that capacitance. Equivalent capacitance is 6C by 11. So 6C by 11 into V is nothing but V only they given. And the next, this is also for this one, the charge flowing through this one is actually the charge formula, Q equal to the C into V. Remember this formula. So now Q equal to C into V. Here also Q equal to C into V. The charge flowing through the fourth capacitor Q4 equal to the capacitance C4 into potential difference across this one is the V. So V. So now we got 4C into V. They are asking the ratio of charges on C2 to the C4. Okay, charge flowing through the charge on the C2 to the C4. That means charge on the C2 is the Q2, charge on the C4 is the Q4. Q2 by Q4 we have to find. So charge on the three resistors, three capacitors is same. So that is equal to the 6C by 11V. Okay, now 6CV by 11, and charge on the fourth capacitor is nothing but 4CV. CV will be cancelled out. Then 6 by 11 into 4 we will get 3 by 22 is the right answer. The ratio is a 3 by 22. Like this solve the problems. See the 10th question. The question is, two identical capacitors have the same capacitance. Capacitance is C. One of them is changed to potential V1, charged to potential V1, and the other to the V2. The negative ends of the capacitors are connected together. When positive ends are also connected, the decrease in the energy of the combined system is. Okay, now here negative terminals connected, positive terminals connected. Initially the capacitance is the C and the voltage is charged up to the V1 potential, and initially capacitance of this one is C and charged up to the V2. Now these are connected by the wire. Okay, then like charges are connected, and either this side also like charges are connected. Then no need to do the derivation, simply remember the formula. So the loss in the energy or change in the energy equal to the 1 by 2 C1 C2 by C1 plus C2 into V1 minus V2 whole square. So this is the formula you have to remember. If you remember this formula, enough you can do within the single step. So here like charges are connected, then we will get the V1 minus V2 whole square. If unlike charges are connected, V1 plus V2 whole square. Remaining term is same, just here like charges are connected, so V1 minus V2 whole square. Unlike, either plus either minus connected, then we will get V1 plus V2 whole square. Okay, remember this formula. Okay, and next substitute the values here. So loss of energy or change in the energy equal 1 by 2. Capacitances are, this is the C and this one also C. C into C by C plus C is nothing but 2C. And this one potential charge to the potential V1, this is charged to the potential V2 only, so V1 minus V2 whole square. So 1 C will be cancelled, 2 into 2 4, so C by 4 into V1 minus V2 whole square. If you remember this formula, within 15 seconds this problem will be finished. Like charges are connected, V1 minus V2 whole square. Unlike charges are connected, V1 plus V2 whole square. Remaining term is same. Remember this formula. Next, come to see the next question, 11th question. Two parallel plate of area are separated by two different dielectrics as shown in the figure. The net capacitance is. Here parallel plates, not capacitors, are in the parallel. Okay, remember that point. Parallel plates. Okay, this is the arrangement they given. These are the parallel plates, and separated by the dielectric constant. So first one ka dielectric constant is 1, second one ka dielectric constant is 2, and the distance between the two plates is d by 2. Here also distance between the two plates is the d by 2. So I am redrawing this diagrams, okay. So here dielectric constant of this capacitor is 1, dielectric constant of this capacitor is 2, and plates ka distance between the two plates d by 2. Here distance between the plates is d by 2. The area is given same, I think. So now here these two capacitors are connected in the series. So find the equivalent capacitance. They are asking the net capacitance, so find the net capacitance or equivalent capacitance. Capacitors are in the series. So capacitance formula already we know, C equal to the epsilon naught to A by D. This is the formula already we know, capacitance. If dielectric material is inserted in the capacitor between the two plates, then capacitance of the capacitor increases by K times. Okay, so now the capacitance of this capacitor increased by the, so then this will become K into epsilon naught A by D. If any dielectric material is inserted between the two plates, if medium is existed, then this formula, if vacuum or air is there, then epsilon naught A by D. So if we keep the dielectric material, capacitance will be increases. Okay, now see, so I am going to find these two capacitors are in the series, so equivalent resistance 1 by Cs equal to the 1 by C1 plus 1 by C2. Here we have the two capacitors. So capacitance formula is, by keeping the dielectric constant, we will get the capacitance formula K into epsilon naught A by D. So 1 by Cs equal to the C1 value. So from this one, K1 epsilon naught A by D1. Okay, so but 1 by C1 is there now, so D will go upside. D1 by K1 epsilon naught A plus C2 also same, K2 epsilon naught A by D2, reverses, D2 by K2 epsilon naught A. Okay, D1 value is nothing but D by 2, and the D2 value also is nothing but D by 2. K1 value is 1, K2 value is 2. Substitute here. D by 2 into K1 value is 1, epsilon naught A. D2 value is D by 2 into K2 value is 2, epsilon naught A. Okay, so this is D by 2 epsilon naught A, D by 4 epsilon naught A. Do the LCM, we will get 3D by 4 epsilon naught A. So the CS equal 1 by CS equal to 3D by 4 epsilon naught A. CS equal to the reverse 4 epsilon naught A by 3D. 4 epsilon naught A by 3D. Like this you have to solve the problems. Okay, next to see the next question. A system consists of two metallic spheres of radius R1 and R2. Here we have the two metallic and the radius. This one is the R1 and this one is the R2. Okay, connected by a switch. Here one switch is there. Initially S is open. It is open. The spheres carry charge. So charge on the first sphere is the Q1. Charge on the second sphere is the Q2. When switch is open. If the switch is closed, the potential of the system is. Okay, potential we have to find. Okay, so already we know the formula. Q equal to the CV and V equal to the Q by C. The potential equal to the charge upon the capacitance. Okay, so now here if it is switch is open, then charge on this one is Q1 and charge on this one is Q2. That means initially the total charge equal to the Q1 plus Q2. The system ka charge is Q1 plus Q2. And next we are closing the switch. If we close the switch, we are not providing any potential to this one. We are not connecting the battery. Just we are closing the switch. Then what will happen? From high potential sphere to the low potential sphere, the charge will be distributed. Okay. But here what will happen? We are not providing any external potential to this one. We are not connecting the battery. Then so some charge from here to here or from here to here, it will be exchanged. But total charge will be conserved. Okay, initially how much charge is there? After closing the switch also we have the same charge, but charge on the this sphere will be changes, but total charge is the same only. So initial charge is nothing but Q1 plus Q2. Finally also we will get the same charge only, Q1 plus Q2 only. And the next capacitance for the spherical capacitance value, C equal 4 pi epsilon naught R. Remember spherical capacitance value is 4 pi epsilon naught R. So this one, the first sphere ka radius is R1, so C1 equal to 4 pi epsilon naught R1. Second sphere ka capacitance is C2 equal to radius is R2, 4 pi epsilon naught R2. Okay, now we have to find the potential. If the switch is closed, the potential of the system is, the potential of the system is nothing but, if the switch is closed, total charge by total capacitance, total charge by total capacitance. After switch is closed, the charge will be distributed, but total charge is how much initially is there, finally also same. So that is nothing but the Q1 plus Q2. So Q1 plus Q2 by capacitance values are C1 plus C2. C1 value is 4 pi epsilon naught by R1 plus C2 value is 4 pi epsilon naught R2. So from this we can take the 1 by 4 pi epsilon naught is a common from the denominator. I am writing here 4 pi epsilon. So in the numerator we have Q1 plus Q2. In the denominator, if you take the 4 pi epsilon naught as a common, R1 plus R2 we will get. So the answer is 1 by 4 pi epsilon naught Q1 plus Q2 by R1 plus R2. B is the right answer. So like this you have to solve the problems. In part 1 you have to remember more number of formulas and do the more applications. Okay, thank you.